Our home floats inside a vast, invisible cavity in space. This is the local bubble, a giant region of incredibly thin and scorching hot gas that stretches for 1,000 light years. By the end of this journey, you will understand how this cosmic bubble defines our place in the galaxy and shapes the very space around our solar system. We will uncover what ancient explosions built this void and what its mysterious walls mean for our future. What does it feel like to live inside a cosmic bubble? Think of our galaxy not as a smooth, homogeneous cloud, but as a block of Swiss cheese. We live inside one of the holes. This specific hole, our cosmic neighborhood, is known as the local bubble. It is a vast, irregular cavity carved out of the interstellar medium, the gas and dust that fills the space between stars. This bubble is immense, stretching roughly 1,000 light years from end to end. To put that in perspective, if our entire solar system were the size of a coin, the local bubble would be larger than the entire continent of North America. Inside this enormous void, the rules are different. The space here is not empty, but it is incredibly thin. The gas inside the bubble is a searingly hot plasma, a state of matter where atoms are torn apart into a soup of charged particles. Its temperature is staggering, soaring to over 1 million degrees. Yet, because this plasma is so incredibly diffuse, so spread out, you would not feel that heat if you were floating in it. It is the ultimate paradox, a furnace so thin it feels like a vacuum. This bizarre environment was not always here. It is the aftermath of cosmic violence. Between 10 and 20 million years ago, a string of massive stars, living fast and dying young, exploded as supernova in our galactic vicinity. Imagine a series of titanic bombs detonating in space, their blast waves expanding outward for eons, sweeping up and compressing the colder, denser gas of the galaxy into a shell while leaving behind this vast, hot interior. We are not drifting through this bubble alone. Our sun, along with a collection of other nearby stars, is simply passing through, all of us temporary residents inside this celestial cavern. So we are not just on a planet orbiting a star. We are inhabitants of a specific and rather unusual structure in the cosmos, a grand cavity shaped by ancient stellar explosions. What does it mean to live inside such a place? This searing void we call home is carved from something far more substantial, the interstellar medium. Think of it as the galaxy's atmosphere, a thin but pervasive mixture of gas and dust that fills the vast expanses between stars. It is the raw material from which everything is built. The overwhelming majority of this cosmic fog is hydrogen and helium gas, the primordial elements forged in the Big Bang, sprinkled with fine grains of dust like cosmic soot. But this medium is not uniform. It exists in distinct phases, each with its own personality and purpose. The most dramatic are the cold, dark molecular clouds. These are the nurseries of the universe, immense and frigid regions where gas becomes so dense and cold that atoms bind together into molecules. Within these shadowy veils, gravity works its magic, pulling the gas into clumps that eventually ignite as new stars and planetary systems. In stark contrast, most of the space between these clouds is filled with a warmer, more diffuse gas. It is thin, but it is everywhere. And then there is the hottest phase, the gas that has been superheated to millions of degrees, becoming a tenuous plasma. This is the state of the gas inside our local bubble. Under normal conditions, this scorching plasma is rare, a fleeting result of violent events, but here it is the dominant feature. So when we say we live inside a bubble of hot gas, we are not just describing a pocket of warm air. We are saying our entire solar system is adrift in an anomalous ocean of this high-energy plasma, a sea that should be a rarity but for us is the norm. This bizarre reality forces a single, compelling question. Our position inside this million-degree void was not always obvious. For a long time, we simply did not know it was there. The discovery required us to learn how to see the invisible, to map the empty spaces by studying the light that travels through them. Astronomers began piecing together this cosmic map by observing the light from distant stars. As that starlight journeys across thousands of light years to reach our telescopes, it passes through the various gases of the interstellar medium. Different elements in the gas absorb specific colors from the starlight, leaving behind unique fingerprints in the spectrum. By analyzing these minuscule dips in starlight, scientists could determine not only the composition of the gas, but also its density and temperature. They slowly built a three-dimensional picture of our galactic neighborhood, and a startling pattern emerged. In every direction we looked, the data revealed a vast region of extremely hot, incredibly thin gas, with our solar system sitting right near its center. We were not on the edge of this structure, we were deep within it. Imagine a map of the Milky Way galaxy, that magnificent spiral disk of hundreds of billions of stars. We are located within one of its smaller spiral arms, the Orion Arm, about halfway out from the bustling center. Now zoom in on our little stellar neighborhood. You would see our sun and its nearby stellar companions all enveloped by a gigantic, irregular cavity. This is the local bubble. Its walls are not solid, of course. They are the accumulated piles of colder, denser gas and dust, the material that was swept up and compressed by those ancient supernova shockwaves. Think of it as a great, slowly expanding foam of hot gas, its surface constantly shimmering and changing, with our solar system drifting through its inner reaches. This is our true cosmic address. We do not just live in the solar system within the Orion Arm, inside the Milky Way. We are inhabitants of the local bubble, a temporary resident of a celestial cavern carved by fire. The architects of this cosmic void were stars that lived spectacularly violent lives. These were not the quiet, stable stars like our sun. They were titans many times more massive, burning through their nuclear fuel in just a few million years. Their deaths were not quiet fades, but cataclysmic detonations known as supernova. Between 10 and 20 million years ago, a string of these colossal explosions rippled through our corner of the galaxy. Each one was an event of almost unimaginable power, outshining its entire host galaxy for a brief, brilliant moment. When such a star exhausts its fuel, its core collapses in a fraction of a second, triggering a blast wave that rips the entire star apart. The outer layers are hurled into space at incredible speeds, a fireball of incandescent gas and radiation expanding outward. This is the shock wave that would sculpt our future home. Think of a sudden, powerful gust of wind sweeping across a dusty plain. It does not just blow the dust away, it pushes it ahead, piling it up into a growing ridge. Now replace that gust of wind with the titanic force of a supernova blast, and replace the dust with the thin gas and dust of the galactic plane. Each successive explosion sent another powerful shockwave racing through space. These waves acted like cosmic bulldozers plowing through the interstellar medium. They swept up the cooler, denser gas, pushing it outward and compressing it into a thick, complex shell. With so much material swept to the edges, what was left behind was a vast, evacuated region, a cavern in the fabric of the galaxy. But this new cavity was not empty. It was filled with the supernova's own remains, a debris field of incredibly hot, ionized gas. This material, heated to millions of degrees by the explosion, expanded to fill the void, creating the searingly hot yet incredibly thin plasma we find ourselves in today. Our local bubble is not the relic of a single, solitary blast, but the accumulated echo of an entire stellar family's dramatic demise. Before those ancient stars exploded, our galactic neighborhood looked very different. The space between stars was filled with a much denser, cooler fog of gas and dust, a quiet and opaque expanse. This was the pre-bubble era, a time of relative calm before a storm of cosmic fire. Then the chain reaction began. Roughly 10 to 20 million years ago, the first of the Titans died. a supernova's shockwave ripped outward, a sphere of incandescent gas and energy that began pushing the surrounding interstellar medium aside. It was like the first strike of a hammer on hot metal, starting to dent the fabric of space. This was not a single, isolated event. It was a series of cataclysms. Another massive star, likely a sibling from the same stellar nursery, reached the end of its life and detonated. Its own blast wave merged with the first, adding its energy and momentum to the expanding cavity. Then another exploded, and another. Each successive supernova acted like another powerful hammer blow on the same piece of cosmic metal, widening the dent, forcing the walls of dense gas ever outward. The cavity swelled over millions of years, a growing void sculpted by relentless concussive force. We are living in the aftermath of that stellar frenzy. Today, the bubble is still expanding, its walls of compressed gas and dust slowly drifting outward into the galaxy. The initial violent push is over, but the momentum remains like a ripple on a pond long after the stone has sunk. This is our current phase, a period of slow, steady growth within a celestial structure that is already immense. But what comes next for our cosmic home? The bubble's fate is not eternal. Its hot, thin interior will gradually cool and lose its energy. In another 10 million years or so, its expansion will likely stall. The immense pressure of the surrounding galactic atmosphere will begin to push back, slowly collapsing the cavity. The walls may fragment, and new clouds of gas could drift in, eventually refilling this anomalous void. Or another cluster of massive stars could be born in the dense shell itself, destined to live fast, die young, and trigger a new cycle of explosions, either reinforcing our bubble or carving out an entirely new one within it. Our residence here is only temporary, a brief chapter in the ongoing story of our dynamic galaxy. These ancient explosions left behind more than just an empty cavity. They forged a frontier. Surrounding our entire local bubble is its shell, a vast and complex boundary that separates our hot, thin interior from the cooler, denser galaxy beyond. This is not a solid wall you could touch. It is a turbulent, shimmering region of accumulated material, a cosmic shoreline where the waves of those long-dead supernova finally crashed and settled. For millions of years, the shock waves from those stellar explosions acted like a colossal snowplow, sweeping through the interstellar medium. They did not destroy the gas and dust, they gathered it. The blast waves pushed everything in their path ahead of them, compressing clouds of hydrogen, helium, and cosmic dust into a thick, massive layer that now defines the bubble's outer limits. Within this shell, the material is a chaotic mix. It contains the swept-up remains of the original galactic gas, but also the enriched debris from the supernova themselves, heavy elements like iron and silicon forged in the stellar furnaces and blasted into space. This shell is dynamic and alive with motion, a churning interface where hot and cold, old and new constantly interact, and within this chaos lies a profound creative power. As the shell continues its slow expansion, it plows into new, undisturbed clouds of gas. The pressure from this collision is immense. It squeezes these clouds, destabilizing them. Imagine a gentle, diffuse cloud of cosmic gas floating peacefully for eons. Suddenly, the advancing wall of the local bubble presses into it. The cloud is compressed, its density skyrocketing in certain pockets. In these dense knots, gravity suddenly gains the upper hand, pulling the gas inward until it collapses under its own weight and ignites into a brilliant new star. The very same force that carved out our void is now responsible for building anew at its edges. The shell of our bubble is not just a relic, it is a stellar nursery, a cosmic cradle where the death of ancient giants gives birth to the next generation of suns. So what does this ocean of superheated plasma actually feel like? The space inside our local bubble is defined by two extreme and seemingly contradictory qualities. It is incredibly hot, yet it is also an almost perfect vacuum. The temperature of this gas is staggering, soaring to around 1 million degrees. At that heat, individual atoms cannot hold onto their electrons. They are torn apart, creating a soup of charged particles known as a plasma. Yet, this plasma is so incredibly sparse, so unbelievably thin, that its heat is almost meaningless in the way we usually think of it. If you were to float in this million-degree environment, you would not feel a searing burn. You would freeze while being gently tickled by the occasional solitary high-energy particle. The density here is almost nothing, just about 0.001 atoms per cubic centimeter. To grasp that emptiness, think of the air you are breathing right now. Every cubic centimeter of Earth's atmosphere at sea level holds about 100 trillion atoms. Inside our cosmic bubble, that same tiny space holds on average just a single lonely atom. It is a vacuum far more complete than anything we can create in our most advanced laboratories on Earth. This ghostly plasma does leave a trace, however. It emits a faint, pervasive glow, but not in the light our eyes can see. This is an X-ray glow, a whisper of high-energy radiation that permeates the entire cavity. Our eyes are blind to it, but satellites with X-ray vision can map this soft emission, painting a picture of the bubble's interior and confirming we are truly adrift in this sea of faint, ethereal light. This bizarre reality, a hot void that feels like nothing at all, is the fundamental environment of our solar system's journey through the galaxy. Our solar system is not a stationary occupant of this cosmic void. We are travelers moving with purpose through the local bubble's searing interior. The Sun, along with its entire planetary entourage, is sailing through space at a tremendous speed, roughly 230 kilometers every single second. This grand voyage is carrying us on a direct course toward one of the bubble's boundaries. We are not merely drifting, we are on an exit trajectory. Current estimates suggest that in just 10,000 to 20,000 years from now, a blink of an eye in cosmic time, we will finally reach and pierce through the bubble's outer shell. Imagine the transition not as a sudden wall, but as a gradual fading from one environment into another. The near-perfect vacuum we currently sail through will slowly give way to a denser, more substantial interstellar medium. The view from Earth or from a hypothetical spacecraft would not change dramatically to the naked eye. The constellations would remain familiar, but the fundamental environment surrounding our entire solar system would be undergoing a profound shift. The most significant change would involve the heliosphere, the vast protective magnetic bubble that the Sun itself blows around us. This bubble is created by the solar wind, a constant stream of charged particles flowing from the Sun. Right now, inside our local bubble, the heliosphere pushes against an incredibly weak external pressure. It can expand to a large and robust size, acting as a sturdy shield against the galaxy's cosmic rays. But as we enter the denser gas clouds beyond our bubble, the external pressure will increase dramatically. The heliosphere will be compressed, shrinking in size. A smaller heliosphere means a weaker shield. More high-energy cosmic radiation from the galaxy could potentially penetrate deeper into the inner solar system, reaching Earth itself. While life on our planet has proven incredibly resilient, a sustained increase in cosmic radiation over millennia could have subtle yet profound effects on our atmosphere and climate, influencing cloud formation and even mutation rates. This distant future transition marks a fundamental change in our solar system's relationship with the galaxy, a slow motion crossing from one cosmic shore to another. We are far from alone in this million-degree void. Sharing our local bubble are a collection of stellar neighbors, some of the most famous stars in our night sky. The brilliant Sirius, the closest star system Alpha Centauri, and the distant but bright Altair all sail through this same hot cavity. Yet despite these famous names, the bubble is not a crowded city. It is a vast, echoing cavern where the average distance between stars is still immense. Every one of these suns, including our own, is on an independent journey around the galactic center, each tracing its own unique path through the Milky Way. For a brief cosmic moment, our paths have converged within this same structure. We are not a fixed family of stars, but more like ships that have all, by chance, entered the same calm bay in the middle of a turbulent ocean, destined to sail out again on different tides. This shared, temporary residence is what makes our current view of the heavens so special. The familiar constellations we see are, in a very real sense, a snapshot of our fellow travelers inside the local bubble. In another few million years, as these stars continue on their separate orbits, this stellar configuration will be gone, and the bubble will be host to an entirely different set of passing suns. Even within our vast, hot bubble, the space is not perfectly uniform. Our solar system is currently sailing through a subtle, localized patch of slightly denser material known as the local interstellar cloud, or sometimes the local fluff. This cloud is a tiny, wispy structure, a mere 30 light-years across, and it is our immediate interstellar environment. Think of the local bubble as a giant, empty hall, and the local fluff is a faint, almost invisible mist drifting through that hall, a mist we have just happened to enter. This cloud is still incredibly thin by any earthly standard, but compared to the surrounding void of the local bubble, it is substantially denser. Its gas is about 10 times more concentrated, and crucially, it is thousands of times cooler than the million-degree plasma outside it. This creates a fascinating interaction right at our cosmic doorstep. The sun's powerful solar wind, that constant stream of charged particles, blows a protective bubble around our entire solar system called the heliosphere. As we move through the local fluff, this heliosphere is plowing through its material. The cloud's slightly higher density and magnetic field exert a gentle but constant pressure on the heliosphere's outer boundary, shaping and compressing it. Scientists study this interaction by observing atoms from the cloud that manage to slip past this magnetic barrier and drift into the inner solar system. By analyzing these interstellar visitors, we can measure the cloud's composition, its temperature, and the direction of its flow. This ongoing research reveals a startling fact. The local fluff is not dense or strong enough to withstand the hotter plasma of the local bubble that surrounds it. The only reason this wispy cloud has not been instantly heated and dissolved is that the pressure from the expanding local bubble is actually holding it together, squeezing it into this temporary, coherent form. We are passing through a fleeting cosmic eddy, a small ripple within a much larger wave, and our journey through it is giving us a front-row seat to the delicate forces that shape the space between the stars. Studying something you cannot see requires a kind of cosmic detective work. Astronomers map this invisible void by observing how it subtly alters the light that passes through it. The primary tool for this investigation is starlight itself, acting as a probe that carries hidden messages across the light years. As starlight journeys from a distant star toward Earth, it travels through the vast expanses of the interstellar medium, including the hot plasma of our local bubble. Atoms and ions within this thin gas absorb very specific colors from the starlight, leaving behind unique, minuscule fingerprints in its spectrum. By analyzing these faint absorption lines with powerful telescopes and spectrographs, scientists can perform a kind of interstellar forensics. They can determine exactly which elements the light passed through, measure the gas's temperature, and even calculate its density. When they do this for thousands of stars in every direction, a three-dimensional map begins to emerge, revealing the vast hot cavity we call home. But there is another, more direct way to observe the bubble's interior. The million-degree plasma inside the local bubble is so hot that it emits its own faint light, not in visible colors, but in the high-energy realm of X-rays. Our eyes are blind to this ethereal glow, but specialized observatories like the Chandra X-ray Observatory are not. They can scan the sky and map this soft X-ray background radiation, effectively painting a picture of the bubble's hot, tenuous interior and confirming its all-encompassing presence around us. To understand the bubble's boundaries, we rely on robotic scouts that have journeyed to the edge of our own solar system. NASA Interstellar Boundary Explorer, or IBEX, creates maps of the boundary where the sun's solar wind collides with the local interstellar cloud. By counting atoms that slip past this boundary, IBEX tells us about the density and flow of the material just outside our heliosphere, the very edge of our local environment within the larger bubble. Even farther out, the Voyager probes have become the first human-made objects to physically cross this threshold, directly sampling the magnetic fields and particles of interstellar space. These distant messengers are our hands and eyes, feeling out the shape and texture of the cosmic cavity we all inhabit. This journey through our cosmic bubble raises a profound question about our own planet's history. Could the grand movements of our solar system through the galaxy have left a mark on Earth's climate? Some scientists propose a fascinating, though still speculative, link between our interstellar travels and the great ice ages that have periodically gripped the world. The theory centers on what happens when our solar system drifts out of a protective environment like the local bubble and into a much denser interstellar cloud. In such a dense region, the sun's protective heliosphere could be compressed, shrinking the magnetic shield that deflects galactic cosmic rays. With a weaker shield, more of these high-energy particles would reach Earth's atmosphere. Here is where the climate connection emerges. Some research suggests that an increased flux of cosmic rays could influence cloud formation in our lower atmosphere. Cosmic rays can ionize molecules in the air, potentially acting as seeds around which water vapor condenses to form more low-level clouds. These bright, low-level clouds reflect more of the sun's light back into space, cooling the planet. It is a chain of events that links a galactic scale change to a planetary scale effect. Our current residence inside the local bubble offers a relatively shielded environment. The hot, thin plasma exerts very little pressure on our heliosphere, allowing it to remain large and robust, deflecting cosmic rays and perhaps contributing to a more stable climatic period. But if our solar system's past voyages took us through dense, cold clouds outside such a bubble, the resulting compression of our protective shield might have allowed for conditions that tipped Earth into a glacial period. We are not saying cosmic rays alone cause ice ages, as Earth's climate is an immensely complex system driven by many factors. Yet this idea invites us to see our world not as an isolated sphere, but as a ship sailing through a changing galactic sea, where the very nature of the space outside our door may subtly influence the weather inside. What other secrets of our past are written not in Earth's rocks, but in the silent, invisible currents of the galaxy? Our cosmic bubble is far from a solitary structure. The Milky Way galaxy is not a smooth disk of stars and gas. It is a labyrinth of voids and walls, a celestial Swiss cheese on an unimaginable scale. Our local bubble is simply our local hole in that cheese, one of many superbubbles that riddle the spiral arms. These vast cavities are a fundamental feature of our galaxy's anatomy, each one the legacy of a massive stellar association. These associations, known as OB associations, are sprawling groups of the galaxy's most colossal and luminous stars. They live for only a few million years, but in that short, spectacular life, they reshape their entire neighborhood. Their fierce stellar winds blowing at millions of kilometers per hour and their inevitable supernova deaths act in concert to carve out these enormous caverns. The combined energy of multiple supernovae can inflate a single superbubble to diameters of 1,000 light-years or more, just like our own. Look toward the constellations Vela and Puppis in the southern sky, and you are gazing at the Gum Nebula. This is another nearby superbubble, a gigantic shell of glowing gas that is the expanding remnant of a series of ancient supernovae. It is so large that its faint filaments stretch across dozens of degrees of the sky. Further afield, in the constellation of Orion, the familiar nebula we see is actually just the bright edge of the much larger Orion Eridanus superbubble. a cavity hundreds of light-years wide, blown clear by the powerful stars of the Orion-OB association. These structures are not isolated islands. They often overlap, merge, and stack together, creating a complex, frothy architecture throughout the galactic plane. Our solar system has likely drifted in and out of many such bubbles over its long history. This grand perspective changes everything. It means that the hot, thin environment we currently enjoy is not a universal constant, but a temporary and local condition. The galaxy is a dynamic ecosystem of violent creation and slow dissolution, and our place within it is constantly shifting. We are not just living inside a single bubble, we are navigating an entire foam of them, a cosmic landscape of voids and shells that tells the ongoing story of stellar life and death across the Milky Way. The next phase of exploring our cosmic bubble is already taking shape, with new eyes and new tools preparing to reveal its deepest secrets. The James Webb Space Telescope, with its unprecedented infrared vision, is poised to study the bubble's boundary in a way we never could before. It will peer into the dense, cold clouds of the shell, analyzing their composition and watching for the earliest signs of new star formation triggered by the bubble's expansion. This is like getting a high-resolution microscope to examine the very fabric of the bubble's walls. Simultaneously, the European Space Agency's Gaia mission is conducting a galactic census of staggering precision. By tracking the subtle motions of nearly 2 billion stars, Gaia is not just giving us a static map. It is creating a movie of our galaxy, allowing us to rewind and fast-forward the movements of the stars within and around the local bubble. We can trace their paths backward to confirm the ancient supernova origins and project their paths forward to predict when we will exit and what we might encounter next. But perhaps the most ambitious dreams lie with proposed interstellar probes. Concepts like breakthrough starshot envision tiny, laser-propelled spacecraft sailing across the void to our nearest stellar neighbors. These nanoscale craft could act as direct scouts, sampling the material of the bubble's interior during their long journey, and eventually piercing the shell itself to report back on the conditions outside our celestial cavern. These missions, from the orbital observatories to the far-flung probes, represent a fundamental shift. We are moving from simply observing our bubble from within to actively probing its structure and understanding our place within its evolving story. The silent, invisible ocean we sail through is about to begin whispering its secrets. This ongoing cycle of destruction and creation is written in starlight across our sky. The shell of our local bubble is far more than a simple boundary. It is a vibrant stellar nursery, actively giving birth to new generations of suns. The same shockwaves that carved out our cavernous home continue to shape its edges with creative force. As these immense waves of energy expanded outward for millions of years, they plowed into the cooler, denser gas of the galactic plane. This was not a gentle nudge, but a colossal, sustained compression. The force was so immense that it squeezed vast clouds of hydrogen and dust, destabilizing them and overcoming their internal pressure. In countless pockets within the shell, gravity finally gained the upper hand. What was once a diffuse, floating cloud began to collapse inward, fragmenting into dense, spinning cores. Each of these knots, heated by the tremendous pressure of its own collapse, eventually ignited into the nuclear fire of a new star. We can actually point to the children of this process. Look toward the constellations of Scorpius and Centaurus, and you are gazing at one of the most significant stellar families born from our bubble's influence. The Scorpius-Centaurus Association is a sprawling group of brilliant, hot, and remarkably young stars, many just 10 to 15 million years old. These stars did not form in the deep, quiet interior of a dark cloud. They were forged in the turbulent, compressed material of the local bubble's advancing shell. Their very existence is a direct result of those ancient supernovae, a testament to how stellar death on one side of a cavity can spark stellar birth on the other. This is the grand rhythm of the galaxy, a cosmic feedback loop where the end of one stellar generation provides the shock, the material, and the perfect conditions for the next one to begin. Our bubble is not a static monument, but a living, breathing entity, still expanding and even now potentially triggering new stars to flame into existence along its dynamic frontier. This searing plasma surrounding us does more than just define our space, it acts as a subtle shield. The local bubble is not empty, it is threaded with weak but pervasive magnetic fields, remnants of those ancient explosions that linger in the hot gas. These fields are crucial, for they interact with one of the galaxy's most pervasive forces, cosmic rays. These are not rays of light, but atomic nuclei, mostly protons, accelerated to nearly the speed of light by distant supernovae and black holes. They are a constant, invisible rain of high-energy particles, and our bubble helps regulate the downpour. As these charged particles enter our local bubble, they must navigate its tangled magnetic landscape. The fields act like a cosmic maze, bending the paths of the incoming particles, forcing them to spiral along magnetic lines in a chaotic dance. This process, called diffusion, slows their progress and scatters their trajectories. The journey through the bubble's interior becomes a long and winding road, and many cosmic rays lose energy along the way. The result is a filtering effect. The flux of cosmic rays that finally reaches our inner solar system is not the full, unfiltered blast from the galaxy, but a somewhat moderated stream. This has direct consequences for the space weather within our celestial cavern. For future human explorers venturing to Mars or establishing bases on the Moon, cosmic radiation is one of the greatest dangers. A long-duration journey outside the protective cocoon of Earth's magnetic field and thick atmosphere exposes astronauts to significantly higher radiation doses, increasing cancer risks and potential damage to the nervous system. Our residence within the local bubble means that baseline radiation levels in interplanetary space are lower than they would be if we were sailing through a dense, cold cloud where our heliosphere would be compressed. The bubble's magnetic fields provide a first line of defense, a galactic-scale buffer that takes the sharpest edge off the cosmic ray storm. This does not make space safe, but it makes the environment within our million-degree home marginally more manageable for the fragile biology of life. It is a reminder that our local cosmic architecture is not just a spectacle, but a fundamental part of our environment, quietly influencing the practical realities of our future among the stars. To truly understand this cosmic cavern, we have to watch it form. This is the work of astrophysicists who build entire galaxies inside supercomputers, creating digital laboratories to test the story of our local bubble. They begin with a virtual slice of the Milky Way as it might have existed millions of years ago, seeding it with a cloud of gas and a cluster of massive, doomed stars. The simulation is governed by the fundamental laws of physics, programmed to calculate the mind-boggling complexities of gravity, hydrodynamics, and magnetic fields. Then they introduce the catalyst. One by one, the simulated supergiants reach the end of their lives and detonate. Each supernova is not just an explosion, but a precise injection of unimaginable energy, equivalent to the force of 1 billion trillion nuclear bombs, all focused into a single point in the digital space. The shockwave from the first blast expands outward, a sphere of incandescent gas and pressure that plows into the surrounding virtual interstellar medium. Before it can dissipate, another star explodes nearby, its own shockwave merging with the first, then another and another. On the computer screen, this violent sequence is transformed into a breathtaking visual ballet. You see a sphere of hot, red and orange gas begin to swell like a balloon inflating in slow motion. Its surface is not smooth but a churning, turbulent front. It pushes against the blue and purple clouds of colder, denser gas, which resist and fold, fracture and pile up. The shock waves do not move evenly. They finger and ripple through the medium, creating a complex, frothing shell. Thin, fiery tendrils of million-degree plasma shoot ahead, while vast, dark pillars of dust are compressed and sculpted. These simulations reveal the sheer chaos of the bubble's birth. It was not a clean, spherical expansion, but a messy, fractured process full of instabilities and unpredictable flows. The models must account for the magnetic fields woven through the gas, lines of force that guide the hot plasma and influence the entire structure's shape and longevity. By tweaking the variables, scientists can test different scenarios. What if the supernova were closer together? What if the surrounding gas was denser? They run the simulation forward in time, watching as the bubble continues to expand for millions of years, its hot interior gradually cooling, its shell beginning to fragment. They can even fast forward to see its eventual fate, predicting when and how it might collapse or be reshaped by new explosions. These digital recreations are more than just movies. They are tests of our deepest understanding of cosmic evolution, allowing us to witness the violent, beautiful events that carved out our home in the galaxy. This unique environment of our local bubble may one day define the first great era of human interstellar travel. For a civilization learning to cross the voids between stars, the bubble's profound emptiness presents a paradoxical mix of obstacle and opportunity. Consider the sheer speed required to make such a journey in a human lifetime. A vessel traveling at even a fraction of light speed would find a dense interstellar medium to be a deadly hazard. Every atom of gas and speck of dust would strike the hull with the energy of a particle accelerator beam, creating a constant, erosive bombardment. Inside our bubble, however, that danger is drastically reduced. The near-perfect vacuum means a starship would encounter far fewer impacts, making high-speed travel through our local cavern a far safer proposition. This is the bubble's gift, a cleared cosmic highway for our first tentative steps into the galaxy. Yet this same emptiness also closes a door on one of the most elegant concepts for interstellar flight. Imagine a buzzard ramjet, a theoretical engine that could scoop up hydrogen from the interstellar medium as it travels, using it as fuel for a continuous fusion reaction. It is a beautiful idea, a self-refueling engine that turns the galaxy itself into its gas station. But here in our local bubble, there is simply nothing to scoop. With just one atom per coffee mug-sized volume of space, a ramjet would starve, its collectors grasping at a vacuum. Our cosmic home, while protecting us, also denies us this particular path to the stars. This forces a fascinating pivot in our vision of the future. Our first interstellar vessels will likely not be elegant ramjets, but instead colossal ships that must carry every gram of their fuel and reaction mass with them from the start, or find another, more exotic means of propulsion. The bubble's nature dictates the engineering. It means that the great arcs leaving our solar system would launch into a relatively clear but resource-barren sea. Their journeys would be one-way trips into a profound emptiness, with the next potential refueling station lying far beyond the bubble's distant walls, in the denser and more resource-rich clouds of the galactic plane. Our local cosmic architecture does not just surround us, it actively shapes the destiny of our ambition, defining the very possibilities of our journey outward. Our cosmic bubble's vast emptiness holds a powerful allure for storytellers. Science fiction has long been drawn to the idea of a human outpost isolated in the void, but the local bubble offers a grander, more authentic stage. Imagine a galactic saga where humanity's entire domain is confined within this million-degree cavern. The stars we see at night are not random points of light, but the only safe harbors in a sea of nothingness, each one an island in the void. The true frontier lies at the bubble's edge, where our civilization presses against a luminous, impenetrable wall of glowing gas and dust. This is not a fictional construct, it is our scientific reality reframed as epic narrative. The dense, unexplored clouds in the shell become the mysterious, uncharted territories of the story. realms where physics might behave strangely and where new forms of life could potentially arise in the stellar nurseries. A starship's journey across the bubble would be a profound test of endurance, not of combat, a long voyage through a quiet, empty ocean where the greatest danger is the sheer psychological weight of the void. This contrasts sharply with many fictional depictions of crowded, bustling interstellar travel. Our bubble is not filled with asteroid belts and alien trading posts every few light years. It is profoundly, overwhelmingly empty. This very emptiness creates a new kind of drama, one of isolation, of limited resources, and of the immense challenge of bridging the gaps between the few scattered points of light. The bubble's scientific nature provides a foundation of plausibility that makes the fiction feel urgent and possible. It transforms our night sky from a simple backdrop into a map of a specific, confined territory, a celestial island chain whose boundaries are real, whose physics are known, and whose silent, hot ocean we are only just beginning to learn how to sail. This million-degree void is our harbor. For eons, our solar system has sailed through this protected expanse, a quiet neighborhood in the galaxy's bustling metropolis. That long-term stability might be far more significant than we once realized. The bubble's hot, thin plasma and its tangled magnetic fields act as a galactic buffer, taking the sharpest edge off the cosmic ray storm that constantly rains down from the galaxy. Outside this cavity, in the denser spiral arms, our sun's protective heliosphere would face greater pressure, shrinking our magnetic shield and potentially allowing more of that high-energy radiation to reach our world. While life on Earth is resilient, a sustained increase over millions of years could have subtly altered the story of evolution, influencing mutation rates and the planetary climate. Our residence here in this specific celestial cavern may have offered a rare and prolonged period of cosmic calm. It invites a profound thought. The development of complex life, leading to us looking up at the stars, did not happen in a random location. It unfolded within a specific architectural feature of the Milky Way, a temporary clearing in the forest that provided a gentler environment for a delicate experiment to run its course. We are not just inhabitants of Earth or the solar system. We are children of the local bubble, our very existence subtly shaped by the boundaries of this ancient, expanding void. The silent, invisible ocean around us is not merely empty space. It is the sheltered waters that have cradled our world for millions of years. Despite the incredible map we have drawn of our cosmic home, the local bubble remains a place of profound mystery. Its story is far from complete, and key questions linger without clear answers. For instance, we know a series of supernovae carved out this void, but how many stellar explosions were actually involved? Was it a dozen titans or perhaps 20? Each number tells a different story about the stellar family that once lived and died here, and pinning down the exact count is crucial for understanding the total energy that shaped our galactic neighborhood. Then there is the bubble's shape. We describe it as a cavity, but its true three-dimensional structure is maddeningly complex. Is it a single, connected chamber, or a series of interconnected voids like rooms in a cavern? Its boundaries are not clean walls, but a tangled, porous frontier of clouds and filaments. Mapping this intricate architecture in full detail is like trying to trace the outline of a cloud from the inside, a monumental challenge that requires more data from every corner of the sky. Perhaps the most elusive puzzle is the behavior of the magnetic field woven through the bubble's hot plasma. These invisible lines of force are the ghosts of those ancient explosions, but how are they oriented? Do they form a chaotic web, or are they stretched into orderly ribbons by the bubble's expansion? This magnetic tapestry is not just a curiosity, it governs how cosmic rays filter into our solar system and influences the very stability of the cavity itself. Every one of these unanswered questions represents a frontier of knowledge. New observations from telescopes and space probes constantly refine our models, sometimes confirming our theories and other times forcing us to redraw the entire map. This is not a settled science, but a dynamic detective story where each clue reveals just how much we have yet to learn about the silent, scorching ocean we call home. That dark window in the sky is your personal portal to the local bubble. On a night far from city lights, when the Milky Way arches overhead as a river of starlight, you can see its structure with your own eyes. You are not looking at a uniform glow, but at a landscape of light and shadow. Notice how the band of our galaxy is patchy, broken by dark rivers and vast, empty bays. These are not voids of stars, but colossal clouds of cosmic dust, so thick they block the light from the billions of suns behind them. Now find the constellation Orion. Look at the region around its famous belt and sword. Here, the Milky Way is not a bright, dense band, but a sparser, more open expanse. You are gazing directly into a clear tunnel through the galaxy's clutter, a tunnel with virtually no obscuring dust in your line of sight. This is not a random gap. You are looking out through the interior of our local bubble. The bubble's hot, thin plasma does not block the light, but its creation cleared away the dense, light-absorbing dust clouds that would otherwise fill this region. Those ancient supernovas scrubbed this volume of space clean, pushing the dusty material out to the distant walls. So when you look toward Orion, you are not just seeing stars. You are seeing through a thousand-light, year-long corridor that was hollowed out by stellar explosions millions of years ago. Your view is unimpeded because you are sitting deep inside the cavern, looking out through its open center. Try this for yourself. Compare the view toward Orion with the view toward the constellation Cygnus or Sagittarius, where the Milky Way glows brightest. In those directions, you are looking into the crowded, dusty plain of the galaxy, where your vision is stopped by countless dark nebulae. But in the clear directions, you are peering down the length of the bubble itself. That sense of depth, that clear window to the distant universe, is your direct, visceral connection to this grand cosmic architecture. The night sky is not a flat painting, but a three-dimensional map, and you are standing at the heart of one of its greatest voids. Our cosmic harbor will not last forever. The local bubble is still in motion, its walls of compressed gas and dust continuing their slow drift outward into the galaxy, but that momentum is gradually fading. The initial, violent push from those ancient supernovae is long spent, and now the bubble expands like a gentle sigh in the cosmos. For millions of years to come, its hot interior will steadily cool, the searing plasma losing its energy and becoming even more diffused. Its magnetic fields, those invisible threads that help shield us, will slowly weaken and unravel. Eventually, the immense pressure of the surrounding galactic atmosphere will begin to push back. The expansion will stall and then reverse. The bubble's identity will soften as it merges with neighboring interstellar structures, its distinct walls dissolving until our local cavity is just another unremarkable patch in the galaxy's complex, frothy medium. This is the quiet, almost melancholic end for our celestial home, a slow fading and a gentle collapse, but the story does not end there. The galaxy is a cycle of destruction and creation. Look at the brilliant, massive stars in our sky today, like those in the Scorpius-Centaurus association. They are destined for spectacular supernova deaths within the next few million years. When the next nearby Titan explodes, its blast wave will rip through the fading structure of our old local bubble. It will not simply reinforce our existing home, it will likely shatter it. That new supernova shockwave, possibly joined by others from the same stellar family, will plow through the interstellar medium anew, sweeping up material and carving out a fresh cavity with its own unique shape and boundaries. Our solar system, by then, will have long since exited the old bubble and could be passing through a dense cloud. The new explosion might envelop us, suddenly immersing us in another hot, thin void, or its shockwave could compress the cloud around us, triggering a burst of star formation right on our cosmic doorstep. We are living in the calm between two storms, a temporary resident of a structure that is both ancient and ephemeral. the local bubble is not our permanent address, but merely our current chapter in the Milky Way's endless story of stellar life and death. We have sailed through the ghostly interior of a cosmic cavity, a 1,000-light-year-wide cavern forged by the deaths of ancient stellar titans. We have traced the path of those supernova shockwaves that swept the galaxy clean, leaving behind a sea of million-degree plasma so thin it feels like nothing at all. This is our local harbor, the local bubble, a temporary and protective home that has cradled our solar system for millions of years. Its dynamic walls are not just boundaries but stellar nurseries, and its very emptiness shapes the possibilities for our future journey to the stars. Our existence here is a fleeting moment in the grand cycle of the galaxy, a calm between the storms of stellar death and rebirth. We are not just passive residents of the cosmos, but active participants in its ongoing story, our lives subtly intertwined with the architecture of space itself. The universe is not a static backdrop, but a living, breathing entity of voids and walls, and we have a front-row seat to its majesty. This grand perspective changes everything. What did you find most astonishing about our place within this cosmic bubble? Share your thoughts in the comments below, and if this journey expanded your mind, subscribe to join us as we continue exploring the futuristic technologies and cosmic lifestyles that define our place in the universe. The next adventure is just a click